Okay, so I want to go over some answers to some questions because it looks like there's quite a few questions from the physics, which I totally expected, to be honest with you. Um, so what I'm going to do is I'm going to start with number 40. 39 and 40 are very, very similar. So if you can do 39, you should be, or if you can do 40, 39 is very similar to it. Just so you know, because I'm not sure the answers in the back of the book are right. So for number 39, the answers that I have are that the final velocity was 6.3 meters per second. And the angle was 41.6 degrees clockwise to the negative x-axis. And I had that the two kinetic energies, one was 12.11 and the other one was 10.2, so not equal, so not elastic. So that's number 39, but I think I had more questions on number 40 than I did on number 39. So I want to look at number 40 with you, and then we'll move on to the other section. I know at least one person said I got the first question and then it just went from there. So number 40 says you have car A has a mass of 1,735 kilograms. And it was traveling north at 45.5 kilometers per hour. And it was going north. Okay, so that's car A. Now, I'm just looking to see. Yeah, I didn't even bother, to be honest with you. I didn't even bother to switch my velocity into meters per second, and I'll explain why in a minute. Car B has a mass of 2,540. And it was going west. It's going west at, no, that's not west, that's east. Someone stop me. I really need you guys here to, correct me when I screw stuff up. Is going west, there we go, at 37.7 kilometers per hour. Now, when they when they meet at the intersection, they collide, and they get stuck together. Their bumpers stick together or something. What was their combined momentum, and was it elastic or inelastic? So what was their combined momentum, and was it elastic or inelastic? So they're going to collide and go off. So our momentum before and our momentum after have to be equal. But I can't look at it all together because this is going in a vertical direction and this is going in a horizontal direction. I'm not going to worry about changing it into meters per second. If you did, that's fine. It should still work. But there's no need to, because again, momentum is kilograms times meters per second. It really is just mass times velocity. So if all your velocities are in the same thing, then it's fine. It's when you're doing formulas where you're doing something that, say, has time and velocity in it. If your time is in seconds, but your velocity is in kilometers per hour, those units don't work together, so you can't do that. But with momentum, it's kilograms and meters per second. And again, because there's no unit that says this unit is kilograms times meters per second, you don't have to switch it. So I'm just not even gonna bother because I don't need to. And so the less work I can do, the better. But what I do have to do is break this up into the x components and the y components. So I'm going to compare momentums before and after. And I'm going to get the x component and the y component. So when we're talking about the x direction, I'll put that over here. When we're talking about the x direction, we're talking about across. We're going to talk about the momentum before, and we're going to talk about the momentum after. So before, we have car A going north. This is car A. We have car A going north. So it's not actually traveling in the x direction at all. So it's 1,735 times nothing. It's car B that's actually going in the x direction, and so its mass is 2,540. And again, I'm just going to use 37.7. Your answer will be different if you change it to meters per second, and that's fine. If you do it one way and I do it another, and I happen to be marking it like it's something you're handing in to me, I will take that into account. Again, sometimes you have to change it, especially if you're putting it into another formula that does rely on it being in meters per second. This just isn't the case here. So after, the momentum after, well, they said they lock together. So after they're 1 unit, so their mass is actually 1735 plus 2540, and I don't know what the velocity in the x direction is. So I solved for that, and I got negative 22.4. And let's think about this logically for a second. I know some of you hate it when I say that, but let's think about this logically for a second. If car A is going north at 40, if you got a car going north at 45 kilometers per hour, and you have another car going almost 38 kilometers at this hour and at an hour at this direction, if they crash, they're not going to go this way, right? They're going to go off this way. It just makes logical sense. So the fact that my x, because if I continue this Cartesian plane, the fact that my x part is negative actually makes sense, because I know logically this car, these two cars, when they lock together, are going to go this way in some fashion. So it makes sense that my x is negative 22.4. That actually makes sense. And again, that's just velocity, right? And so then I'm going to do the y direction. And so we'll do the y's up here, I guess. For the y direction, the before, car A is all y direction before. And car B is not going in the y direction at all. So, whoops, I put the wrong thing there. It doesn't really matter, but it should have been mass. 2540 times 0. And that's going to be equal to, again, they lock together, so the masses are together. I added them together and got 4,275. So that's just those two numbers added together, times the velocity in the y direction. So I did that math, and I figured out that the velocity in the y direction was 18.47. And again, it makes sense that it's positive, because it makes sense that the cars are going to kind of go off in that direction. So 18.47. So I can figure out the final velocity by using Pythagorean theorem. I'm going to do 22.4 squared plus 18.47 squared, and I'm going to take the square root of that, and that'll give me the final velocity overall, which I got was 29.03. And I can figure out the angle, because I can do tan of y over x. So 18.47 over 22.4. Again, I don't worry about the negative when I'm figuring out the angle. So I figured out that the angle was 39.5 degrees. You could round that off to 40. 39.5 degrees. Now that is this angle right here. Now because this is talking about north, south, east, west, what is that? Well, that is west 39.5 degrees north. I still haven't answered their question because they wanted to know the final momentum and whether or not it was elastic or inelastic. So momentum would be mass, which the mass of them together was 4,275 times the velocity. Now if you use the 29.03, your momentum's going to be different than if you put it into the other thing that I can't think of, meters per second. So I'm just looking in my little solution thing, and I'm just checking to see what I did here. Yeah, so I didn't bother to switch it, and I got 1.24 times 10 to the 5th. So I didn't bother to switch it. If you did, and you got an answer different from that, it's probably because you switched it into meters per second, and that's fine. Then it wants to know if it's elastic or inelastic. Again, you can cheat a little bit on this. We want to know the kinetic energy before and the kinetic energy after. And so, again, it's 1/2 mv squared, but because the only velocity, it's just velocities in there. There's no time, there's no units for it to have to agree with. I can just leave it in kilometers per hour if I want to. It's not technically in joules then, but it still will tell me whether they're equal or not. I can't give my answer as there was this many joules because I'm going to figure out kilograms and meters per second squared rather kilometers per hour squared rather than meters per second squared. So it's not technically a joule, but I'm only looking to see whether they're equal or not. I don't actually care how much kinetic energy they have. All I care is whether they were equal or not. So the before would be 1/2 the first car's mass times the first car's velocity squared plus 1/2 the second car's mass times the second car's velocity squared. And when I worked that out, I got 3.6 times 10 to the 6. Afterwards, it would be 1/2 the mass of both the cars, because now they're locked together, times the velocity, which is 29.03 squared. And I got 1.8 times 10 to the 6. So the question is, are those equal? No, they're not, so it's not elastic. Again, I'm not saying that there's that many joules because technically that's not a joule because I left this as kilometers per hour, but it is legal to do that. Now, if you are more comfortable putting it into meters per second so that it's just the habit that you always do, that's fine. You can do that, but I'm giving you the shortest route possible to the answer, all right? Okay, I'm gonna stop there and I'm gonna make another video for the next section, okay? So just a sec.